Hey all, good morning, good afternoon, and good evening to everyone, right? So today we are here uh, to learn about PostgreSQL and Power BI course. Okay. Now, just to give a small introduction about this particular course, PostgreSQL and Power BI. Okay, I just want to give you all know hack training, agile, hands-on agile coaching, right? So Lakshmi Nune is working hard to get more courses to the students because in this IT world, right, there are a lot of streams are there. Like when you see in education, there would be a lot of subjects are there. Similarly, in the IT world also, there are a lot of subjects, right? So Lakshmi is trying to connect the dots by making sure getting the nice recruiters, teachers, trainers at one place, and he want to create a hack academy kind of thing. So as a part of that discussion, we connected and we have a discussion that we want to create a course based for the data analytics role, right? On that basis, again, I got another request from him that the students who are reaching out to Lakshmi, okay, they are like a new to IT world or they want to switch their career from non-IT to IT world. So these are the two driving factors while I'm preparing this course. So then I got the idea of Power BI. Okay. So Power BI is a business intelligence tool, okay, that analyze the data, huge amounts of data, and creates a nice dashboards and visualizations for the management or for the operational purpose, right? Now, and the reason for selecting Power BI is it's a Microsoft Office tool. So the good thing is whoever working on the laptops or computers, definitely they will have some hands-on with Microsoft Office tools like MS Word, PowerPoint, like this. Okay, basic understanding. And you see Power BI, when you started working with Power BI, you feel that it's a already you worked on it because its user interface, its options more or look close to these Microsoft Office tools. And it is a open source one or free of cost initially. So that is the reason I have selected Power BI. Okay. Because when I come to the business intelligence tools, we have some other tools like Tableau. Okay. And other tools also there, but they are a bit complex. They do more jobs. I mean, they are a equal competitor for Power BI, but at the same time, learning them is a bit difficult. So on that reasons, we have picked up Power BI, right? This is the first step. Along with Power BI, whenever we are focusing on a role of data analyst, right? Or data scientist, not scientist, data analyst or Power BI developer, it is good to have knowledge on SQL, right? So SQL, that means structured query language. So SQL is a kind of a universal language in the database world. Like you remember English, right? English is a universal language. If you learn English, it's easy to for us to communicate across the countries, majority of the countries. Similarly, SQL, learning SQL helps us to handle with any kind of data confidently. Okay. So that is the reason I decided, okay, along with the Power BI training, okay, we will be adding the SQL also. And when it comes to the SQL, we have different databases, SQL Server, Microsoft SQL, Oracle, Teradata, all these are there. Out of this, Postgres SQL is a open source. Open source means you don't need to pay anything. It's a free of cost. Okay. And it has having the UI user interface. That means we can work from the front end and also we work from the back end. Back end means it looks like a black screen. We just give the commands and it executes. Right. So on these two things, I thought that, okay, let us club PostgreSQL and Power BI so that it will become a nice combination. If you see in academies, you will have the major subjects along with you will be having minor subjects also. Okay, so if I interpret in that way, our Power BI becomes a major subject and PostgreSQL becomes a minor subject. Okay, so on this context end, if you see here, our course contains Power BI and PostgreSQL. Along with, we have a data warehousing concepts, right? Now, wherever you go, okay, not about IT field, non-IT field, anywhere, fundamentals, concepts is very important. Will you agree with me or not? Fundamental concepts. Hmm? So, first of all, when we are talking about data analyst, data scientist, data engineer, whatever we say, guys, can you go on mute, please? Or
Fine.
let me
Don't put
mute.
French water, just a drop.
Apologize, guys. I just muted everyone. If you have any doubts, kindly post in the chat channel. I'm going to watch the chat channel regularly and I'm going to get back to you. Hmm? Ha. Fundamentals. Okay. Trust me, in every field, the student or a person who has a sound knowledge on fundamentals, crystal clear understanding about the fundamentals, his journey would be very smooth. Okay. When we are doing a job, we need to understand what is the purpose of that job, right? If we are not knowing that one, then at some point of time we feel that okay, why we are doing? Is it really a value added, right? So whenever we are saying data analyst, data reporting and everything, the fundamental concepts is data warehousing. The names are changed based on the data that we are collecting. Earlier in 19th century, when you say the database, it just collects the rows and columns. Okay. But with the technology evolving, we have the requirement to collect images, documents, pictures, all those things. Now, warehouse has become lake, data lake. Okay. So we are going to see all those concepts. So our entire course is divided into three parts: data warehousing concepts. The first one, okay, it we are having one class. After that, PostgreSQL, we are having 4 to 5 classes, and next Power BI 10 to 11 classes. Okay, so we are going to have total 15 classes. Okay, each class of 1 hour, weekdays, and after the class recording would be shared along with the assignments. Let me show you one sample assignment. Okay. So you all are going to get a assignment mail from me. Suppose if I open this one, okay, it is going to have the class number and the topic we covered and our batch. What is this batch? Suppose this batch is 12th August batch. Okay. In this one, I'm going to share our class recording. Okay. The first thing before you joining the next class, what you need to do, okay, that review once again our class recording and whatever the topics that I provided, that you need to go through them and complete the questionnaires, that is means assignments. So I'm going to give the assignments. Trust me, whatever we are learning in today's class, 40% is going to be repeated in the next class. So which means if you are familiarize yourself with today's class, your tomorrow's class will be more and more easy and you can be more attentive and it will be more interesting. Okay. I request every student, right? Please don't think that, okay, I will complete my assignments on weekend. I would be having more time. A weekday, I'm busy. No. How you are able to manage to get 1 hour to join this class? Similarly, create another 1 hour time for yourself. before coming to the next class. That is my polite, gentle request. Okay, so that we can easily learn parallelly. I mean, having the class, having the practice, both the things in parallel. Okay, so this is all about our class, and each class would be recorded and uploaded in the YouTube link so that you can easily watch them wherever you go. Okay, so this access is provided to the Gmail IDs you registered, you provided to me. Okay, so my kind request is make sure you are opening your YouTube with the same Gmail ID, right? Okay. Any questions or queries on the class structure, how we are going to go, and what was our practice strategy during the class? And I'm going to open the class 15 minutes before, and after the class, I'm going to be there for 15 to half an hour for any questions and queries. Even we are going to review the assignments shared by the students in the next class. Okay, we first complete the review of completed assignments and then we will start the class. So you just consider it's like class would be like 1 to 1.5 hours. Okay, minimum 1 hour 15 minutes, maximum it goes to 1 hour 30 minutes or 40 minutes. Any questions or queries? Okay, so as and when class is going on, when we are coming to the third week, okay, we would be focusing on certifications, okay, and also resume preparations. And if you see the opportunities, okay, let me show you some links. If you see, these are all the links those we are posting to our students on a daily basis. Where it is. This is our previous batch. No, where it is. Yeah. Okay. So there are a lot of openings. Just 1 second. Yeah. If you see, these are all the jobs those we are posting to our students regularly. Okay. Suppose if you see USA, let me open this one. See, Power BI developer, digital charter is seeking for talented, motivated Power BI report developers, full-time remote position. Key responsibilities: develop, design, and maintain Power BI reports, create and maintain dash flows. Qualification: bachelor's degree, 4 to 5 years of experience, proficiency. If you see, 95,000 per year, full-time. Okay, for a 4 to 5 years. Similarly, if I open another Glassdoor, Microsoft Power BI developer, MCore. Okay, there is a enormous opportunities are there, and we are having, we as a team are working on to get you trained. Okay, and also guiding you on the available positions and helping you to apply those jobs also. Power BI reporting in contractual remote. Okay, so yes, Bukalo, can you post your query over the chat channel so that I can answer your question? Kindly post your queries in the chat channel. Okay. See, Thursday, Friday. There is enormous opportunities are there for Power BI developer. Good thing is it is easy to learn. Okay. And we have a lot of opportunities in the industry because almost every industry is now moving to the digital mode of transactions, digital mode of payments, everything. See, Naresh is the one going to help us on this one. We continuously send open positions to our team members in the WhatsApp group. Okay. So that all together, along with this one, Even we guide each and every student, okay, personally one to one, to understand what is his what learn, how much he has learned, and what is the best way to apply the jobs, and what are the best things that we need to do to get the calls from the recruiters. Okay. Okay, let me stop sharing and pause recording once. Okay. So in our first class, I hope, yeah, I hope I am audible and clear and you are able to see my screen. Okay. So as I told you, right, we have divided our class into three parts. The first part is data warehousing concepts. That's a today's class, right? And the second part, we are going to cover about PostgreSQL database to gain good knowledge on SQL and database concepts. These would be covered in the first week. And in the second week, we are going to touch our Power Query. I mean to say Postgres, Power BI. And third week also, we are going to cover Power BI. Okay. So coming to our first class. Just 1 second. I just want to show you one nice picture now. Okay. This one. If you see this diagram, data to insights, this is going to be our journey. Okay. So whenever we are starting a journey or anything, first of all, we need to understand, right, what is our destiny. That is the first thing, where we want to go, right? So ideally, it's not a good thing that we should first decide where we want to go. Okay. Sometimes we can do a random journey also without knowing the end point, just like adventurous thing. But good thing is, first of all, we need to know what is our target. And second thing is, in our journey, how we want to go. What is our mode of transport? Okay. And that depends upon our financial budgets, time constraints, all those things. Similarly, now our journey is data to insights. Okay. So in the current world, with majority of industries moving towards the IT, everything is being captured in the systems, right? I'm just giving a simple terminology to avoid any confusion. Just systems, that's it. It can be your laptop, desktop, everything, because that is what we see in front of us. So one of our student working in pharmacy, some are working in the school, right? So they know whenever they go to their office, they open this laptop and there would be some application would be there, a front end application, right? That shows a form where we fill all the details and we click on save button. Details are saved. Suppose if you are near the sales counter, you are the sales associate. A customer comes with bag of items and you scan the QR code. Immediately it displays on the user interface screen, and finally you click on save button so that bill would be generated. So in this way, millions, trillions of data is being generated in the current world. And where we are storing them, each company has their own ways of storing the data. Some are storing in the files, right? We all know from earlier days of the computer, data is stored in the files, text files. Later on, we got the Excel files, Microsoft Office, right? Even one Microsoft Excel file can act like a database. It can maintain the data for a mid-range organization. That kind of features are there in the Excel sheet. Okay. And as technology evolving, right, we got the database concepts, right? And further, where we discussed just couple of minutes, right? Storing data is not just about storing some kind of a rows and columns. Now we have the requirement to store the images, files, documents. Earlier, if you see, if you have an application form, we use it to fill that application form, and there would be a data entry operator. He used it to type all those application form in the system, and he used it to save that file. Okay, that's a data entry job. At one point of time, that job has a lot of demand. Okay, now technology has changed. Now we have got the scanners. Now what happening? That entire application is scanned and it is stored as a form of image. Now to store these images, we need a ecosystem that we called as data lake, right? We all know that lake, right? Lake is a like a water body, but it's going to have lot of things, not just water, right? It's going to have a biodiversity, algae and everything. Similarly, so whenever you want to create ecosystem that can store not just about rows and columns, but it can store images, files and everything, then we call it as a data lake. Okay. So now as a Power BI developer or data analyst, our main focus is we are going to understand about this data factory. In this factory, we are going to have a databases that can act as a data warehouse, or we are going to have a real-time data. At the same time, we are going to have data stored in Hadoop file systems. Okay, so I'm just telling you in a general, simple English terminology. If you have any doubts for any particular wording, you just post it in the chat channel. I'm going to help you. Okay, enter this data is connected to our Power BI, and we are going to create nice visuals from this Power BI. Okay, so this is our journey. Our main objective is to understand a process that helps us to convert all our data into a meaningful dashboards or meaningful images. Okay, that is our journey we are going to cover. So as a part of journey, we are going to cover all this. Yes, Bernard, what is your question, please? Bernard, can you post your question so that after answering that one, I will go to the next topic. Who cleans the data for us to analyze? Yes. So we are going to have data engineers. Okay, so it depends upon the organization. If you have the data organization, okay, so data engineer takes that responsibility. He will use the extract, transform and load tools, okay, to get the data from different source systems and load it. Okay, so once we have the data loaded, and if it is in a clean format as per our requirement, then we are going to use them directly. Or else our Power BI is also having the future to transform and clean the data as per our requirements. Okay, so our Power BI has the future to clean the data and transform it. Okay, but if it is a big chunk, then there would be ETL process, extract and load transform, that cleans our data. Okay, now let us see what is data warehousing. Okay, so as I told you, right, we have handpicked articles. So trust me, I have taken some articles especially for this course. So it's all about just you need to read them and understand, right? A data warehouse is a central repository for information that can be analyzed to make more informed decisions. Okay, it's a central repository of data Okay. Now I want to just take a small diagram. Let me use this Excel sheet. I want to show you one data warehousing diagram. Let me insert some picture, online picture. Yes, data. I just want a simple, yeah, this one. A simple diagram. Okay. So for your information, all the databases are represented in this form. Okay. This is the shape that is used to represent a database. Okay. Now we are talking about data every time whenever we, now this word is going to come up every time. Okay. Data is all about the information. Suppose you go to the pharmacy, right? You purchase some medical items. So you will get a bill. So the bill is going to have each and every line item of your transaction. So that is a data. Similarly, when I go to the bank and I do some bank financial transaction, that is a financial data. Okay. Now, when you see in the organizations, some big organizations, what happened? Since their organization is very big, okay, so they are going to have their sales data where all the data related to the sales, purchases, transactions, and everything. Okay. Now, say this first one is sales data. Similarly, considering they are having a big organization, they are going to have a lot of employees, correct? And whenever you say employees, all the activities done by employees need to be captured, right? Like their salaries given, their office attendance, right? And their any other activities. So that means we are going to have some HR, human resource database that is going to capture all the activities related to employee. Similarly, you are going to have a finance department. And finance department, what they do, they will capture all the financial transactions and they will need to summarize them, right? So similarly, so we are going to have different database for different departments. Even suppose a finance department, what they do is they are not going to have much data. So what they do is they will maintain those data in the Excel files. Okay. Now, at one point of time, like as a management that we need to understand, okay, what is my total sales, right? And whenever we want to become a data analyst, we just need to think like a boss of the business. Okay. Just think of it. If you're boss for a particular business, what the first thing you want to know? Okay, how many sales I have done? What is the profit I got? How much money I am spending on salaries, right? If we are a boss to a company, these are the queries that we are going to comes around our mind, right? So to do these things, obviously we need to aggregate the data, sum up the data. Suppose you are going to have sales data in this one, right? And you sum up all the sales data and you get a report. This is your total sales. You have a HR system in that, suppose you would be having all the expenses that is incurred on employees. So that is going to have the employees. Now what happened? Already these systems are heavily utilized by the online activities, right? So whenever I say online activities, that like our day-to-day activities. So your business is open morning 9 a.m. Sales are happening. Those are online activities. Now at the same time, when you are trying to do a reporting on it, so whenever you want to know what is our total sales, then you need to scan entire table and pull the data and do the transformation. Now just think of it. If you have a system that is good enough to handle these both the things, both operations, that is fine. But at a time, This may impact the performance of the systems also. So what they decided is, even in 1990s only, okay, doing the online activities and analytical activities on the same system is not good. Okay, this is the origin for these data warehousing concepts, reporting, analytics, and everything. So what the leadership team has observed is, okay, one system seems to be not good. In case of any performance issues happen, it will impact the business, day-to-day business operations also. Okay, it's not good. So let us do one thing. Just leave the systems for only the online transactions or online activities. Okay. At the end of the day, you just take a copy from each of the system, copy of whatever the new records added. Suppose today we have a business done, 10 records are there. So these, at the end of the day, after our business closed, we are going to copy these 10 records. Okay. So this process is called staging layer, staging. Similarly, tomorrow there are another 5 records are added. Only these 5 records are pulled. Okay. So this process of getting the data where there is a change, we call it as a CDC, change data capture. What we call it? If I put here, change data capture. Okay. Why this point is very important is because we want to maintain the history in our data warehouse. So that means every day, whatever the changes happen, that I just need to get that information. Okay. So once we have this data in the staging layer, then we rearrange this data based on business domains like summarized data, raw data, metadata. Summarized data means, suppose I have 1,000 transactions. I aggregate those transactions based on each and every product, and I store the summarized data so that for analytical people, it's easy. Suppose I want to know what are the sales for a particular product, I can pull from the summarized data. Similarly, I keep the raw data as it is. In future, suppose if I want to drill down my historical data analysis, then I can go for the raw data. Or in case if I want to build a new kind of report, then I will use the raw data. Similarly, metadata. Metadata means information about your data. Okay. That means what kind of tables I have. Within the tables, what are all those columns? Each column is storing what kind of information that is stored in metadata. Okay. So from this warehouse, and again, I'm going to create a small marts. Okay. Data marts. Suppose a team is there. They want to focus on purchasing patterns so that they can create more new offers. And another team is there. They want to analyze the sales data so that they can focus on marketing. And there is another team that they need to know inventory that is currently present so that they can order new products to the meet the demand. So like that. Okay. So if you see, if I divide this as a part, this left side part is called online systems. And we also call online OLTP, online transactional processing, OLTP. Okay. The name itself tells you easily. It's a OLTP. That means this part deals with the online things. Okay. So all the online data, everything would be stored. And to effectively maintain our systems, so we are distributing the analytical part separately. Now the right side part from warehousing, we call them as online analytical processing. OLAP. Trust me, this concept is going to come in your entire career. Okay, wherever we go in the data analytical part, right? So the simple thing is that data warehouse means it's a combination of storing the data here. Central repository for information that can be analyzed and make more informed decisions. Data flow into data warehouse from transactional systems. Here it is, transactional systems. These are all the transactional systems. Relational databases, so RDBMS, these things also relational databases, and typically on regular contents. Business analyst, data engineers, data scientists, decision maker can access the data through business intelligence tools. So business intelligence tools means our Power BI, Tableau, anything, right? Data and analytics have become indispensable. Okay, this point we need to note, okay, because at a time we got a ghost other. We need to clean the data means whoever doing the analytics part, okay, it's very important and that he should be having a knowledge on the data that on which data on the data that he is going to do analysis. Okay, it's not like that. Okay, thus I have a data engineer, he looks into data. I don't know about it, but I do the analytics means as an analyst, we need to be having good understanding with the analytics also. Okay. So business users rely on reports, dashboards, and analytical to extract insights from their data, monitor business perform, and support decision making. Data warehouses power these reports, dashboards, and analytical tools by storing data efficiently to minimize the input and output of the data. So, for the end users, analytical reporting and mining, this data warehouse acts like a source system that our analytical team or our Power BI team is not going to hit the online systems to get the data. Okay, we are going to rely on the warehouses. And yes, in the warehouse, the data would be stored in a clean and transformed form. Okay. And data warehousing is also a database only. Okay. But just the way it is used changes the name as data warehouse. Okay. So a data warehouse architecture is made up of tiers. The top tier is front-end client that present results through reporting and data mining. The middle tier consists of analytical engine used to access the analyst data, and the bottom tier is the database servers. Okay, so it's a three tier. The top tier is like a reporting where we are going to create a Power BI report, and the middle tier is going to be the our data warehousing, which is like a clean cut. Where is this diagram? Yeah, here it is. The data marts, right? And the lower tier is about the databases that are used to store the data. Okay. What are the benefits of using data warehouse? Informed decision making, consolidated data from many sources, historical data analysis. As we told, right? Here we are going to maintain the raw data. So raw data means we are going to maintain all the history. Data quality, consistency, accuracy. These three are very important. Okay. How we can say that our data warehouse is in good shape, that it is having a right quality, consistency, and accuracy, right? And the main point is separation of analytical process from transactional process, which improves performance of both the systems, right? So since we are separating two heavily processing things into separate systems, so their performance would also be good enough, right? So similarly, how do data warehouse, database, and data lakes works? So this is what we learned, right? A database is a kind of a, if I apply this to our individual way of living, right? If you take a city, right? It can, no, not city. Huh. If you take a house, okay, if you're taking our house, it can be a database, right? So within the house, we are going to have different rooms, right, for each and every purpose. And they can become a tables. Let me put some in the simple diagram, okay? Uh, Insert shapes. Where is this database symbol? Yeah, okay. So if I take a database, okay, it's like our house, right? So we are not going to leave our house like a big hall or with a single room, right? Again, what we do, we just partition our house into small rooms, right? Now each room can be like a one table. Like we are having a room for kitchen, we are going to have a room for bedrooms, and we are going to have a playroom hall like that. Similarly, based on the data, suppose if you have the customer data you need to store, then we are going to have a customer table. If you want to store the sales data, we are going to have store the sales table. Further, these tables are combination of rows and columns. Okay, just correlate this one to our day-to-day life. So whenever we are learning a new thing, when we are correlating that one to our day-to-day life, it would be very easy for us. Okay. Hmm. So furthermore, we will be seeing in our PostgreSQL understanding. Okay. So that is what. Now there is a clear articulation comparison. So a data mart and data warehouse. Now what they say is data mart is also a data warehouse. Okay. There is nothing difference between data mart and data warehouse. But only thing is that a data mart is a subset of data warehouse. Suppose we build a data warehouse for an organization, say Walmart. Okay. Now Walmart is having different departments. So giving access to entire data warehouse to everyone is not a good idea. So now what they decided is, okay, I will create a small subset of this data warehouse, okay, that contains the data related to, say, electronics department. So that means they create a small part of from the actual data warehouse and they create a electronics department data warehouse, and that would be given access to the only for that particular department people. Okay. So a data warehouse and data mart are like vice versa. Okay. Data mart is a subset of data warehouse that is going to store a particular uh, business processing data or particular branch related data like that. Okay. So this is all about an introduction to data warehousing, and we have seen OLTP and OLAP, right? Now we have two great scientists, W.H. Inman and Ralph Kimball. Okay. So these two scientists has introduced the concept of data warehousing and how they are supposed to build. Okay. So let me take that article for you. Okay. And they are the two great scientists, and they have proposed this particular theory in almost in 1980s or 90s. Okay. So if you remember Newton's laws, everyone have heard about that one, right? Okay, that Newton laws are introduced in 19th century long back, but still now rockets are going into the space on based on the Newton's law, Newton's third law, right? So this is one classic example on to know the importance of the fundamentals. Okay, if we are clear with the fundamentals, then we are not going to get any confusion later on days, right? Now, what these two scientists are saying us, so they have come up with the proposal. What is this one? Okay. So what they said is that Kimball approach to design data warehouse was introduced by Ralph Kimball. That's why he had kept his name. If I provided any approach, then I give that it's a Hari theory. Okay. So this approach starts with recognizing business processing and questions that data warehouse answer. Now, what Kimball is saying is that, okay, if you see this image, okay, boss, you have different data coming from different source systems. You are having data from sales team. Okay. Similarly, you are having data from finance team, marketing team. Now, what you should be doing is you create a data mart for each and every department. Okay. And then you merge all those data mart into one data warehousing. So that on this data warehousing, you can create your reporting and everything. So people who are having a knowledge on Scrum Masters, if you apply this one, like it says that instead of going in a big bang, you just start with one department, like a iteration, like a sprints. Okay. Identify a team or a department and start creating the data warehousing for it. That means collect the data, transform it, store it in a summarized form for the sales department. That becomes one data mart. Okay. This is what Kimball has proposed. Now, Inmon approach to design the data warehousing was Bill Inmon. And what Inmon is saying is that, no, don't go with the department level. Okay. Get your all the source systems and create one data warehouse at the enterprise level. Okay. Don't go with the department wise, boss. You have data coming from, say, 5 to 6 systems or 10 systems. Get all those data, keep it at one place. So, and call it as enterprise data warehouse. Okay. And just summarize this data, create, store, and create data warehouse. And from there, now you create a small data marts by creating a views or images and give it to each department. So he's saying that, like, okay, work like a big bang. Get your entire data at one place so that you would be having full control. So what it is saying is the data warehouse is very flexible to change. Business process can adjust very easily because everything's sitting at one place. Reports can be handled across enterprise level. ETL process is very less prone to errors. Since everything is sitting at one place, they are saying. Now, can you tell me which theory is the best one? Is it Kimball or Inmon? Just as per your understand till now, which one you want to go? Suppose if your organization says, okay, boss, build a data warehouse. So we are going to see those differences also. Okay. Okay. Siddharth want to go as Inmon so that his entire data would be sitting at one place. Okay. And he can easily manage the things. Anyone? Okay. Bukola is also Inmon. Fine. Now let us compare the both of them. Okay. So what it says. So introduced by Ralph Kimball, that has he has given his name. Similarly, Inmon approach. Kimball's approach is bottom-up approach, right? Bottom-up approach means suppose if you see an organization, within the organization you are going to have different departments. Now what Kimball says that okay, each and every department, I am going to sit with them. I will create a data mart so that again I will get all these data marts at one place. And in vice versa, in Mons is a top-down approach, right? So at the top level, you are going to sit and work on it. Data integration. This is one of the important thing which we need to know. Okay. So it focus on individual business areas. Yes. Whether it's a sales, whether it's a marketing like that. Whereas InMon focus on the enterprise wide, that is business area. Building time, it is efficient and takes less time. So this is the benefit that we see, that we have a one point for building the time, because yes, you can sit with one department and you can work with them and you can build it. It is complex and consumes a lot of time. Obviously, right? Because whenever you want to build enterprise, that you need to get all the departments. You need to understand how each and every department works and what is the kind of data it is capturing. So InMon is a bit complex one. Cost wise, it has iterative steps and cost effective. Yes, we don't need to put a initial upfront cost, right? Initial cost is use and development cost is low. Okay, initial cost is use. Just think of it. If we want to deal with multiple departments, obviously we need to engage all those departments. Engaging more people means in an organization, that means it have the initial cost is high. But once it is done, then later on maintenance development cost would be low. That is one thing. Skills required is does not need such a skill, but generic team will do the job. Obviously, because when we see a department, if you take a person within that department, yes, he would be having a good knowledge of that particular process, flow, and everything. So it's easy to maintain. But in Inmon, as we need to integrate departments across, that it needs a specialized skill. I think for Kimball, this is the minus point here. Here maintenance is difficult. The reason because every department creates their own data mart. That means just if you take an employee, right? Suppose sales department creates an employee table. Similarly, marketing department also need an employee table in their data mart. That means they are going to create another employee table. So in this way, there is maybe maintenance would be difficult because you can see repeated tables or repeated information. Whereas in Mon, it is maintenance is easy, right? Data model. It prefers data to be denormalized model. It prefers data to be normalized model. Okay. Now I just need around 10 minutes of your time, okay, to understand what is normalized and denormalized. Okay. Because this concept, normalization and denormalization, is very important and it is going to travel along with us. Okay. So before going to this topic, guys, since we have introductory class for around 30 minutes, so we would be taking another 20 minutes more. Okay. Just please be uh, uh, supporting me. Okay. Because it's not like that 1 hour means we should be closing 1 hour. Okay. So another 20 minutes is required for us to complete the first class. Okay. Just giving a heads up so that you don't think that, okay, when is class going to close? Okay. Ha. Normalize and denormalization. Okay. So Kimball says that his warehouse architecture prefers to have a denormalized data, whereas Inmon says it's a normalized data, right? Now, first of all, let us understand what it mean by normalization and denormalization. Okay. For this one, I have a data. Let me open one of my practice sheet I have kept for this exercise. Normalize and denormalize. Okay. So I have two, not two. I have one table for a denormalized. Okay. This table is in a denormalized form. Okay. And below this one, I have a normalized sales table. Okay. but it is going to have some supporting tables also. Okay, now I am going to explain it. Just think of it. Whenever we are doing a shopping, okay, I have an shopping mall nearby me. Okay, so I regularly go to that one to for all my purchases. Okay, now what happen if that particular shopping mall is going to collect my information? Every time I go, he is collecting all my information. Okay, suppose if I purchase a mobile on a particular day, he is going to collect my address. Similarly, laptop is collecting my address. Okay, similarly, again, another person has gone for mobile purchase. He's going to collect his entire address. And he goes multiple times so that every time he goes, entire information is being collected. Okay. So that means we are storing the data as it is in a single table. Now just think of it in a metro city. If a person is visiting a particular mall 100 times, that means his address is going to stored 100 times. Will you agree with me? Similarly, if you have a customers of 100 customers and they frequently visit that particular mall, every time they visit and they purchase something, if they are storing their information as it is, that means we are storing the data repeatedly, same data repeatedly. That means we call normally in database terminology duplication, right? So whenever you are storing a data repeatedly, right, with the same thing, and think of it, if it's a big organization, that means we are storing millions of customer data hundreds of time. Okay, that means lot of space is being utilized. But is it really space utilized? No, space is wasted. Okay, because same information we are storing multiple times means data redundancy. Okay, so and we all know, right, all our hard disk, I mean, to store the data we need to have a hard disk, and that comes with a cost, and that means we are wasting our money. So the thing is that whenever we are storing the data in a single table, okay, for a particular sales and everything, then we call it as a denormalized because it should have all the information. Okay, and at a times we repeatedly. So to avoid this one, a normalization concept has came. Okay, what normalization does is that I know that a customer would be going to visit to me, right? A customer. Then what I will do is for Harish customer information, I create a customer table. Okay, here it is. And I'm going to store his name, date of birth, address, city, and everything. Similarly, I have a products. Say if you take a laptop, we need to have more information about laptop make, model, what is its processor and everything, this kind of information. So I create a table called product table. Okay. And I store one liner, all the product information, right? So whenever someone comes and do the transaction, instead of giving his entire information, I just store his unique ID, customer ID. And whenever I need this customer details completely, then I will join this table with the customer table and get his information. Correct? Similarly, whenever I want to store the address details of the particular customer, okay, I'm going to store address details of each customer in the address table. So instead of storing the address multiple times, I'm going to store this address at one time. Okay. And I'm going to refer this address unique identifier in my transaction table. So just think of it here to store the address. If I need some 20 to 30 bytes, Now I'm going to just store the address in 1 byte or one single digit. That means I'm reducing my space utilization exponentially. Instead of storing 30 characters, I'm just storing one. Okay. If I say I have 100 customers, say 100 customers, so max to max, this is what the number I'm going to store. Okay. If I have 10,000 customers, then max it will go to till this much. Correct? So normalization is a concept of splitting the data into multiple tables, okay, in a logical way so that the data redundancy would be reduced. Okay. Is it clear now? What is normalization? Even if you take the customer address, okay, in the customer address, we are going to have whenever we say customer address, we are going to have customer name, address, city, and state, right? Just think of it in a city, California, we are going to have 1 million, uh, 1 million population, right? So again, what I'm going to do every time instead of writing California, I have a table called city table. Well, I will give a unique number for each and every city and I will refer this one. Okay. So whenever I want the address of this particular customer, this table in turn refers to customer address and pull the customer name and address. Further, for his city and state, it will be referring the city table. Okay. So this way of storing the data in multiple tables is called normalization. Is it clear? Normalization and denormalization. Okay. So to make sure how we can know that address ID in the sales table is connected with the address ID in the customer table. Okay. In the database system, we create a relationship. Okay. With some keywords. And that's why we called a database management system as a relational database management system. So these tables are given a relation between them. And that is the reason we call them as a relational database management system. Is it clear? Normalization and denormalization. I'm happy to explain this again, okay? Because this is going to be traveling along with us. A small minor confusion on this particular concept will derail your learnings. Because at a time, students come back to me ask, hey, Harish, why we are storing data in this many tables? How these tables are interrelated? These two questions, we should be 100% accurate. Okay. Because you are going to get a data warehouse to you and ask to create a Power BI dashboard. So that means you need to know how the tables are interrelated in the data warehouse. Then only you would be able to pull the details from multiple tables and create a nice visualization. Okay. And we are going to have a data model also, that also we are going to see. Now to show you this particular relationship, now we have right sales table connected with address table and address table connected with city table. Okay. Now let me show you this in a diagrammatic form. And I am going to tell you what we are going to call it. Yes, Siddharth, in normalization, we will keep the unique identifier. Okay. Why we will keep the unifier? I will tell you one thing. Suppose this particular table, address table, okay. Here we need to have a unique identifier. Then only, right? Suppose in the tails table, if you have one address ID, when it comes to this table for reference, if it is having two IDs, I mean, suppose even address ID one is there for Ajesh and one is for Michael. Then it will have a conflict of interest, right? It won't know which record to be picked up. So we should be maintaining unique IDs in the reference table. Okay. Yeah, we are joining directly only now. When you join directly, that this reference table refers to the address ID 1. Okay. And we call this table as dimension table. Dimensions. You remember, right? Hey, what are the dimensions that we have? Okay. So let me show you one diagram here. Where is this one? Yeah. And if you see here, the article which I taken is from the Power BI only. Let me show you this one in diagrammatic representation. See, it's unusual for a Power BI semantic model to be compressed a single table. Okay, with the current world, we won't be able to manage our database systems with one table. Definitely, we should be having multiple tables. A single table model can be simple design, perhaps one that's suitable for a data exploration task force, but not one that an optimal model design. Okay. An optimal model adheres to star schema design principle. And this star schema refer to a design approach that commonly used in relational data warehouse designers. Please mention this one. Star schema refers to a design approach that's commonly used by relational database data warehouse designers because it presents a user-friendly structure and it supports high performance analytical query. Okay. So if I show you the diagram, entire air get cleared. Let me show you the diagram. See here. Now, if you see this one, we have the sales table, right? This is what we discussed here. Say here, sales table. Now, this sales table is surrounded by customer address, customer profile, and product profile. If you see here, this sales table is going to have connected with product table, sales order table, customer table, and sales territory table. So in the sales table, we are going to store unique identifiers, I mean, key values and the aggregations. And these surrounded table are going to have a detailed information of each and every item. And we call the center table as a fact table, facts. Okay. It stores the facts about the transactions, about the observations, about the activities. And these surrounded table stores the dimensions about the product information, customer information, or employee information. Okay. And if you see this one, if you see here, we have a center table and it is connected by multiple tables. That's why we call this approach as a star schema. Okay. And this is very, very important. Okay. This concept is part of data warehousing, but if you see the Power BI also saying the same thing, if you see here, this point. An optimum model adheres to star schema design principle. Star schema refers to a design approach that's commonly used in relational data warehouse designers because it presents a user-friendly structure and it supports high performance analytics. So why Harish has added data warehousing concepts as one of the first class? Because even if we say our Power BI is advanced dashboard tool and everything, but it is following the data warehouse concepts which has came out in 1990s. Okay, so we should be 100% cluster clear about the data warehousing. Okay, the I can directly start Power BI by showing some nice colorful dashboards and everything. Okay, but that's not a good way. Okay, we should be first of all building the foundation. Okay, in every foundation is very important. Even if you are constructing a building, foundation. So this data warehousing is like a foundationals. Okay. Now we have seen the diagram, right? The design principle is called star because it classifies model table as either facts or dimensions, right? In a diagram of fact table forms the center of the star, while dimension table, when placed around the fact table, represents points of the star. Okay. I'm going to share you this article that you are supposed to read and understand and revert back with the assignments to me. See, the role of fact table is stored to accumulation of rows that represents observations or events. Okay. Observations means suppose if you are collecting some temperatures, weather reports and everything, that is observations. Events means suppose if you are purchasing in a shopping mall, if you are doing a money transactions, all these are all events, correct? That records a specific business activity. See, for example, event that are stored, sales fact, sales orders, order lines. You could also use fact tables, stock daily currency. Dimension table describes your business entities. Remember this one. Even if I show you this one, our basic example, these dimensions table describes our entities like address entity, customer entity, product entity. Correct? Commonly and products concepts, a date dimension is a common one. Okay, date dimension is common one because whatever we analysis we do. Okay, what is my last week sales, last month sales, close, right? Each dimension table must have a unique column which is referred to as a key column, right? Just now, one of our student has raised a question, right? Siddharth. It is very important. Each dimension table must have a unique column. Okay. This unique column becomes as a foreign key in the fact table. Okay. We are going to study those concepts, primary key and foreign key relations. Okay. The unique key column does not contain duplicate values and it should never have missing values, right? Obviously, unique primary key means it should be not null. It should not be not null. I mean, simple logic. If you have a student ID, okay, student ID should always be unique, correct? And it should not be not null also. If a student ID is null, then how can we know about him, correct? Like product key, product ID, additional. No comparison. See, a dimensions table stores business entities. Fact table stores events and observations. Table structure includes key columns and descriptive columns for filtering and grouping. The dimension table is going to have a key column and descriptive about it. Supports what is the product name, product type, and all those things. Similarly, dimension tables like columns and numeric measures typically contains fewer rows because if you take a customer table, it would be having some list of customers. They are not going to change. Can contain numerous rows. If you take a sales table, daily lot of new transactions would be happening. Query purpose to filter and group to summarize. Okay, so same thing is given here. Star schema. Okay, and suppose if this product table is further referring to any other table. Okay, suppose if you take here, this address table is again referring the city table. Suppose if it is just one level, we call it as a star schema. But if it is multi-level, suppose a dimension table further referring another dimension table, say customer address table is referring to the city table to get the city information, then we call it as a snowflake schema. Okay. So you have two schemas are there. One is star schema and another one is snowflake schema. Okay. So is it clear with respect to the normalization and denormalization and star schema, fact and dimensions. We covered three topics. So it's like a flow. I want to explain normalization and denormalization that in turn taken us to the star and snowflake schema. Within that, we learned about facts and dimensions. Correct? So if you see, these are the T topics. They're like everything is interrelated. But when you start with Inmon and Kimball, we landed in star normalization and denormalization. From there, we came to the star schemas and normalizations. Okay. So this is all about introduction. Okay. The last point for Inmon and Ralph Kimball is in these source systems are highly stable because they change. Source systems have high rate of change. Okay. So just let me come back to our today's topics. So we covered introduction, right? We have understand about online transactional processing and online analytical processing, what they are. And we learned about Ralph Kimball and Inmon theories, like how Newton theories are important in science. Kimball and Inmon theories are very important in the data world, whoever want to become a data analyst. Okay. And we understand data warehousing and data marts. Okay. Snow and star and snowflake schema, data normalization and denormalization we have seen. And we have seen what it is facts and dimension tables. Correct? So let me pause the class here today.